So we are on to our next lesson, which is about erosion, transportation, deposition, and depositional landforms. So again, here are the different learning competencies that hopefully at the end of this chapter, you guys must be able to achieve. Right, so first of all, another degradation process is erosion. Now the question is erosion the same as weathering? From the previous lesson, you learned that weathering is the physical breakdown or chemical alteration of rocks by certain elements in the environment. In comparison, erosion is the process of transporting weathered sediments by agents of erosion into different places. As you can see in the picture on your left, it shows the relationship among weathering, mass wasting, and also erosion. Okay, so there are different agents of erosion, and weathered materials are removed from the original site and transported away by natural agents. And these agents derive their energy from the sun through the water cycle and through differential water heating. So different agents of erosion would include water, glacier, and then finally wind. First of all, water. So, running water is the primary agent of erosion on Earth. Most running water is found in streams and rivers, and there are different types of water erosion, each with their own effects. The first one, we have splash erosion. We also have sheet erosion. We have gully erosion, valley erosion, bank erosion, coastline erosion, and then finally we have seaside cliff erosion. Okay, so let's discuss them one by one. First of all, we have splash erosion. So, what happens in splash erosion is that raindrops cause tiny particles of soil to be detached and move out. In sheet erosion, raindrops break apart the soil structure and move downslope as water flows over land as sheet. Next, we have gully erosion. So, after a heavy rain, water flows in narrow channels, eroding gullies into great depths. Next, we have valley erosion, wherein the continuous flow of water alongside land and downward movement deepens a valley. Next, we have bank erosion, wherein the continuous flow of water wears out stones along bank of streams as well as rivers. Next, we have coastline erosion, wherein waves from the ocean and seas crash onto shorelines and break down rocks into pebbles and reduce the pebbles into sand. Sand is also removed from the beaches, changing the coastline. And then finally, we have seaside cliff erosion, wherein the ocean waves battering seaside cliffs bores holes that may become caves. And the continuous pounding of waves may create an arch that may fall, leaving nothing but rock columns called sea stalks. Next, we have the next agent, which is glacier. So, glacier is a large moving mass of ice, and they are found in many parts of the world, especially in the poles or in high mountains. Now, glaciers are capable of great erosion, and they can erode land through plucking and abrasion. So, plucking is the process wherein fractured bedrocks are incorporated into the ice. This occurs when ice water penetrates the cracks and joints. As the water freezes, it expands, loosens, and pulls out the rock fragments. This, in turn, makes the rock fragments become part of the glacier. The abrasional effect of glacial movement happens when the ice and its load of rock fragments slide over a bedrock. The abrasion smoothens and polishes the surface underneath. The result of the abrasion may be a rock flour or a pulverized rock and glacial striation on the bedrock surface. Now, the effect of glacial erosion varies and it depends on the following factors, which are the rate of movement, the thickness of the ice, the shape and the hardness of fragments contained in the ice, and the erodibility of the surface beneath the ice. Next factor or agent, we have wind. So we have to recall that wind is formed by differences in pressure due to differential heating of the atmosphere by the sun, and that wind carries dust, sand, and volcanic ash from one place to another. Now, in dry areas, strong wind wears away soft rocks, also polishes rocks and cliffs until they are smooth. Wind can also erode materials until nothing is left. And for instance, in deserts, wind blows sand to form sand dunes. Okay, now we move on to transportation. There are several factors that affect the transportation of particles, and it includes the particle weight, size, shape, surface configuration, medium type, resistance of particles to be detached due to cohesive bonds between particles, and other factors that are environmental in nature. For wind, transport velocity can be affected by variation in spatial heating and cooling, which create a pressure gradient. In a stream, the transport of sediments is influenced by slope, discharge, and channel shape. Now, the question is, how are the materials transported? And these materials are transported in four distinct ways. And this includes solution, wherein materials are dissolved in water and carried along by water. Next, we have suspension, wherein the suspended particles are carried by a medium, which can be air, water, or ice. We also have traction, wherein particles move by rolling, sliding, and shuffling along eroded surface, and these occur in all erosional agents. And then finally, we have saltation, which happens when particles move from the surface to the medium in quick, repeated cycles. The repeated cycle has enough force to detach new particles. Now we move on to deposition. So, the process of weathering, mass wasting, erosion, and deposition are responsible for the continued reshaping of the Earth's surface. The agents of erosion are also called agents of deposition. And deposition is the aggregation or accumulation of weathered sediments to create different landforms. Now, first we have water and how it forms landforms. Now, whenever stream velocity decreases, the stream deposits the sediments it carries. Now, the material deposited by a stream is called alluvium. Some may be temporary because the materials may be carried again and eventually carried to the ocean. Materials such as sand and gravel may be deposited in a longer lifespan as deltas, alluvial fans, floodplains, and natural leaves. Okay, so first of all, delta. So a delta is formed when a river loses energy as it flows into an area of slow-moving water such as lake or sea. Now, when the river meets the sea, clay particles coagulate and settle in the seabed. The water flows into a delta through distributaries. So, distributaries are part of a stream that leaves the main flow. Next, we have alluvial fans. Now, an alluvial fan is formed when a stream reaches a flat area or gently sloping plain. When the velocity of the stream slows, it loses its capacity to carry sediments and deposits them at the junction of the hill and piedmont, forming fan-shaped deposits. Next, we have floodplain. Now, a floodplain is a flat, wide expanse of alluvium that covers flat areas which are prone to flooding. A sheet of silts is deposited after successive floods, increasing the reaches of the soil as well as its height. Next, we have leaves. They are formed by successive flood over several years. When a river overflows along banks, its velocity decreases, leaving coarse sediments deposited to form a small, natural embankment alongside the channel. As the water spreads out, fine sediments are deposited over the valley, forming gentle slope of leaves. Next, we have glacier and landforms. So glaciers pick up and transport huge load of debris as they move across the land. Ultimately, these materials are deposited when glaciers melt. In general, all unsorted deposits of rock formed directly by the ice are called glacial till. Next, moraines are layers of ridges of till, and a long pile of rocky material at the edge of a glacier is what we call as a lateral moraine, as shown in the picture. while a pile at the middle of the glacier is a medial moraine. Esker is a winding ridge of sand and gravel deposited under a glacier by water melting from the ice. Drumlins are elongated features composed primarily of glacial tilts, and they often occur in clusters called drumlin fields. Keims are conical hills that are formed when a stream deposits sediments in a depression of a glacier surface. Okay, so like water in glacier, wind is considered as a significant agent in the formation of landforms. Accumulations of wind-blown sediments are usually found in dry lands and along sandy coasts. There are two types of wind-blown deposits, and these are loess and dunes. So first of all, loess is a blanket of silt carried by wind in suspension and deposited over broad areas. And over years, dust storm deposited this material. When loess is cut by streams in road building, it tends to maintain a vertical cliff. Do you know that the thickest and most extensive loess is found in western and northern China? Loess can build up to a height of 100 meters. Next, we have sand dunes, which are deposits of coarse materials in the shape of hills or ridges. So dune is a general term to describe any mound or ridge of wind-blown sand rising to various heights of up to 50 meters. Dunes are found in deserts or above low-lying coasts where sand is constantly renewed by onshore winds flowing across the sandy beaches.